strange object in space has caught the attention of some of the world's top scientists, and it's causing quite a stir. A Harvard professor has suggested that what seems to be a comet might actually be a piece of alien technology. The object, named 3I Atlas, entered our solar system traveling at an incredible speed of 58 kilometers per second, making it the fastest interstellar visitor ever recorded. But it's not just its speed that's raising eyebrows. When astronomers first spotted it in July 2025, it was glowing much brighter than any normal comet should at that distance from the Sun. That brightness made many experts question whether this thing was really a natural object at all. What if, instead of being a chunk of rock or ice, this interstellar traveler is actually a spacecraft powered by nuclear energy, possibly sent by another civilization to observe how humans react? This question, raised by Harvard professor Avi Loeb, has stirred major debate in the scientific community. He explained that if the object were transmitting a signal, it would need a transmitter as strong as 1 gigawatt, roughly the same power output as one of Earth's nuclear reactors. That's no small thing. Such power could easily send messages across light years of space, suggesting the object might not be just another random rock drifting through the stars. The idea might sound like science fiction, but some real experts believe it's worth serious consideration. They point out that nothing about this object behaves like a typical comet. It doesn't move or shine the way ordinary space rocks do. Its strange behavior suggests it could be something else entirely, perhaps even an artificial craft, designed and launched by beings far more advanced than us. The discovery itself was an accident. It happened thanks to the Asteroid Terrestrial Impact Last Alert System, known as ATLAS, which operates from Chile. ATLAS was built to detect asteroids that might come close to Earth, giving scientists early warning if anything threatened to hit our planet. On that particular night, the system wasn't even searching for interstellar objects. It was simply running its usual scans for near-Earth asteroids when something unexpected appeared in its view, a bright, fast-moving object that didn't match any known asteroid pattern. Almost immediately, every warning system in the Atlas Observatory triggered alerts. The object's speed, brightness, and trajectory were so unusual that the system's anomaly detection software flagged it as something extraordinary. When astronomers looked closer at the tracking data, they realized they were observing an object unlike anything seen before. At first, many scientists assumed it was just another comet entering the solar system. But as they continued to study it, they found inconsistencies that didn't make sense. For one, its brightness didn't follow the normal rules. Comets usually glow because sunlight reflects off their icy surfaces or because their ice turns into gas as they warm up near the sun. But 3I Atlas was glowing intensely even when it was still very far away from the sun, too far for ice to melt or vaporize. That meant its light might be coming from something else entirely, maybe even some kind of energy source within the object itself. Another strange feature was its movement. The object's path through the solar system didn't perfectly match what gravity alone should cause. That means something, perhaps a force coming from within the object, was slightly altering its trajectory. A few scientists suggested this could be caused by gas or dust escaping from the comet, giving it a tiny push. But others argued the data didn't fully support that. If the object wasn't behaving naturally, could it be under some kind of control? This mystery reminded many astronomers of another famous interstellar visitor, Oumuamua, discovered back in 2017. That object also came from outside our solar system, moved unusually fast, and had characteristics that didn't quite fit any known natural category. It too sparked debate about whether it might have been artificial. Now, 3I Atlas seems to be reopening the same questions, but with even more unusual details. Avi Loeb, who also studied Oumuamua, believes scientists shouldn't dismiss the possibility of alien technology too quickly. He argues that if humans are capable of sending spacecraft like Voyager or Pioneer into interstellar space, then it's reasonable to think other civilizations could have done the same, maybe long before us. To him, 3I Atlas could be evidence of such a probe, perhaps sent to explore or observe solar systems like ours. Still, not everyone agrees. Many scientists remain cautious, saying extraordinary claims need extraordinary evidence. They warn that there are still many unknowns about how interstellar comets behave, and unusual data doesn't automatically mean aliens. Natural explanations, even rare or complicated ones, should always be tested first. Yet, even the skeptics admit that this object is one of the strangest ever seen, and it could teach us a lot about space beyond our solar system. As telescopes across the world continue tracking 3I Atlas, researchers are gathering as much information as possible before it disappears back into deep space. Its speed means it won't stay in our cosmic neighborhood for long. Scientists are analyzing its light patterns, motion, and composition, trying to understand what it's made of and how it moves. Every new observation adds another piece to the puzzle. The debate over 3I Atlas goes beyond just one object. It touches on a deeper question about humanity's place in the universe. Are we truly alone, or are there other intelligent civilizations out there, perhaps far older and more advanced? If 3I Atlas turns out to be a natural object, it will still be a remarkable discovery that helps us understand how material travels between stars. But if there's even a tiny chance that it's something artificial, that would change everything we know about life beyond Earth. For now, all scientists can do is watch and wait. The mystery object keeps moving through the solar system, glowing brightly against the dark backdrop of space. Whether it's a comet, an alien probe, or something no one has imagined yet, it reminds us how little we still understand about the universe. Each strange discovery like this pushes us to look closer, ask harder questions, and stay open to possibilities that might once have seemed impossible. Even if 3I Atlas turns out to be just another natural phenomenon, it has already achieved something incredible. It's made people all around the world look up again, wonder what's out there, and imagine what kinds of civilizations might be watching us in return. The sky is full of mysteries, and sometimes, all it takes is one bright, fast-moving object to remind us that the story of the cosmos is far from finished. The strange object known as 3I Atlas has puzzled scientists even more after new data revealed that its orbital eccentricity is far above 1.0. In simple terms, this means it's not looping around our sun like the planets do. Instead, it's moving so fast that the sun's gravity can't pull it into orbit. It's just passing through our solar system before continuing back out into deep space. Think of it like throwing a ball. If you toss it lightly, it arcs and falls back to the ground. But if you throw it hard enough, it escapes Earth's pull completely. That's what 3I Atlas is doing. It's flying through our solar system at such high speed that it will never come back. Scientists have rated it on a kind of mystery scale, where 0 means it's definitely a natural object, like a comet, and 10 means it's a piece of alien technology. Right now, no one knows exactly where it belongs on that scale, but the data continues to raise eyebrows. What makes this object even more fascinating is its path. Before we look at where it's going, scientists have tried to trace where it came from. Astronomers first spotted 3I Atlas on July 1, 2025, using the Atlas Survey telescope in Chile. Later, they found older images of the same object, called precovery images, taken by the Zwicky Transient Facility in June. These earlier pictures helped confirm its exact movement across the sky. From this data came a shocking realization: the object's path isn't controlled by the sun's gravity. That means it didn't form in our solar system and has no connection to it. It's a visitor from deep space, just passing by. So naturally, the next question was, where did it come from? By studying its speed and direction, astronomers traced its likely origin to a part of the Milky Way known as the galactic thick disk. This is a region that lies above and below the galaxy's main flat disk, filled with very old stars and thin clouds of gas and dust. It's not an easy place to study because the stars there are ancient, and the background light is faint and cluttered. That might explain why this object wasn't seen earlier. It came from a direction that made it almost invisible to Earth's telescopes until it was already very close. 3I Atlas is traveling at a staggering speed of 58 kilometers per second, faster than any comet we've ever seen. To put that in perspective, that's more than 200,000 kilometers per hour. Its motion through the solar system is so extreme that some astronomers think it's one of the most energetic interstellar travelers ever detected. What's even more unusual is the angle of its approach. It seems to have come from a direction where Earth-based observatories have the hardest time detecting objects, almost as if it was deliberately avoiding early detection. Of course, that's probably just coincidence, but it's a strange one nonetheless. Because of its incredible speed and odd behavior, scientists believe 3E Atlas could be extremely old. Some estimates suggest it could be between 3 and 11 billion years old, possibly older than our solar system itself. If that's true, this object may have formed in a completely different star system long before the Sun was born, and it has been drifting through the galaxy ever since. Over billions of years, it might have crossed vast stretches of interstellar space, passing countless stars before finally entering our solar system by chance. To find out more, astronomers use data from Gaia, a European Space Agency mission that precisely tracks the positions and motions of billions of stars. They ran simulations going back millions of years to see if any known nearby stars could have thrown this object out into space. When a planet or star passes close to another, gravity can sometimes slingshot small objects, sending them speeding away into interstellar space. But after countless tests, no nearby star matched the conditions needed to explain 3E Atlas's current trajectory. There was simply no clear source that could have launched it. That left scientists with two main possibilities. 1. It's a natural chunk of ancient rock or ice that was somehow ejected from a long-dead star system billions of years ago and has been wandering the galaxy ever since. Or 2. It's an artificial object, possibly made by an advanced civilization, designed to travel between stars. The latter is, of course, far more speculative, but it's the kind of question that excites astronomers and the public alike. Even if it is natural, 3E Atlas is unlike anything we've ever seen. Its brightness, its speed, and its trajectory all stand out from known interstellar visitors like Oumuamua or Borisov. It's moving so fast that it will spend only a short time within the reach of our telescopes before disappearing forever into the darkness of space. That's why scientists all over the world are racing to collect as much data as possible while they still can. Telescopes from Chile to Hawaii are tracking its every move, studying its light to determine what it's made of. By breaking down the light it reflects, astronomers can detect traces of elements or compounds, clues to whether it's icy like a comet or metallic like an asteroid. Early readings, however, haven't provided clear answers. It doesn't emit gas or dust the way typical comets do, and yet it shines brighter than it should. That strange glow remains one of the biggest puzzles. Some researchers have suggested that cosmic radiation over billions of years could have changed its surface, making it unusually reflective. Others think it could be rotating in an odd way, causing sunlight to flash off it like a mirror. But to those who lean toward the technological theory, the brightness might mean something else, perhaps that the object has reflective panels or even some kind of energy system still functioning after eons of travel. As 3E Atlas speeds closer to Earth, it's not posing any danger, but its strange behavior has sparked worldwide curiosity. Online communities, science channels, and space agencies are all buzzing with theories. Some call it an ancient alien probe, others believe it's simply a rare cosmic relic from the early universe. Whatever it is, it's reminding everyone that our universe is still full of mysteries waiting to be uncovered. Once it passes by, 3E Atlas will continue on its way, leaving our solar system behind forever. It won't return, and humans may never see it again. But the data it leaves behind could help scientists understand not just this one object but the entire history of material traveling between the stars. For now, though, as it races across the sky faster than any comet in history, 3E Atlas continues to captivate imaginations and challenge everything we thought we knew about the cosmos. Whether it's a relic of the galaxy's ancient past or a message from somewhere beyond, one thing is clear: it's a reminder of how vast, mysterious, and unpredictable our universe truly is. The mystery around 3I Atlas keeps getting deeper. The Hubble Space Telescope has been closely observing it, capturing detailed images that show something truly unusual. Its brightness doesn't match anything in our existing astronomical records. The light pattern, or luminosity profile, that Hubble is detecting has a much sharper change in brightness than any known comet or asteroid in our solar system. In simpler terms, it shines in a way no other space object ever has. this strange behavior is forcing scientists to rethink how they classify objects in space. At first, the readings seemed so extreme that researchers thought there might be a mistake. The object appeared to be glowing far brighter than any comet should at its distance from the Sun. To be sure, several major observatories checked the data independently. The Lowell Discovery Telescope in Arizona, the Canada-France-Hawaii Telescope on Mauna Kea, and Chile's Deep Random Survey Observatory all confirmed the same thing: the readings were real. 3I Atlas was emitting, or reflecting, light at levels that shouldn't be possible for an object that far away. When scientists tried to calculate the object's size based on that brightness, the results were just as shocking. Normally, astronomers estimate the size of a distant object by comparing how much sunlight it reflects to known models. The brighter something appears, the larger it usually is, assuming it reflects light like a natural surface would. Using these standard formulas, 3I Atlas would need to be around 20 kilometers wide to produce the brightness we're seeing. That's enormous, roughly 40 times bigger than either of the last two interstellar visitors, Oumuamua and 2I Borisov. If that size estimate is even close to correct, this is by far the largest interstellar object ever detected. Now, to understand just how strange that is, it helps to look back at those earlier discoveries. The first time astronomers ever saw an interstellar visitor was in 2017. It was a small, cigar-shaped object that zipped through our solar system and quickly disappeared into the distance. Scientists named it Oumuamua, a Hawaiian word meaning a messenger from afar arriving first. That name turned out to be perfect, because it truly was the first known object to come from another star system. Oumuamua didn't behave like any known asteroid or comet. It had no visible tail, no gas emissions, and no dust. It moved through space with an eccentricity, a measure of how stretched its orbit is, of about 1.2, meaning it wasn't bound to the Sun's gravity and was just passing through. Its shape and motion were so odd that even professional astronomers couldn't agree on what it was. It seemed to accelerate slightly as it left the solar system, even though there was no visible gas pushing it forward. Some experts suggested it could be a fragment of a larger body, or maybe a chunk of hydrogen ice that evaporated invisibly. But others, like Harvard's Avi Loeb, thought the evidence pointed to something more radical: an artificial object, possibly a probe or a light sail created by another civilization. That idea sparked huge debate across the scientific world, because it was one of the first times a respected academic publicly argued that an alien technology explanation might actually fit the data. Then, in 2019, another interstellar object was found, this one named 2I Borisov. Unlike Oumuamua, Borisov looked more like a traditional comet. It had a visible tail and released gas as it approached the Sun. Its behavior matched what scientists expected from a natural icy body traveling between star systems. Because of that, it didn't attract nearly as much controversy. Borisov was important because it proved that interstellar objects really do visit our solar system from time to time, they aren't just one-time anomalies. Now, with 3I Atlas, astronomers are seeing something that seems to combine features from both Oumuamua and Borisov but on a much larger and more intense scale. It's as if this object took the strangest parts of both earlier discoveries and amplified them. Like Borisov, it's traveling fast and clearly comes from beyond our solar system. But like Oumuamua, it glows in a way that doesn't make sense, with no visible tail or signs of vaporized gas to explain its brightness. What makes the situation even more puzzling is how bright it appears compared to its distance. Most comets only shine brightly when they get close to the Sun and their icy material starts to melt. But 3I Atlas was glowing strongly even when it was still far from any real heat source. That means something else must be responsible for the light. Some researchers think it could be unusually reflective, perhaps coated in metals or frozen minerals that bounce sunlight efficiently. Others think it might have its own internal heat source, like radioactive material slowly releasing energy, a theory that would make it extremely rare among known natural objects. If it truly is about 20 kilometers wide, 3I Atlas would also be carrying a tremendous amount of kinetic energy due to its speed. Traveling at nearly 58 kilometers per second, its motion through the solar system would create a detectable disturbance in the thin interplanetary medium. instruments have been monitoring whether any surrounding dust or plasma reacts unusually to its presence. So far, data is limited, but early readings hint at subtle electromagnetic changes near its path, something scientists are eager to study more closely. The combination of all these factors, its extreme speed, enormous size, and mysterious brightness, has left astronomers divided. Some believe it's just an unusually reflective natural object, while others think it might represent something we've never seen before, possibly even technological. Harvard's Avi Loeb once again has pointed out that if you assume it's artificial, many of its strange properties start to make more sense. Its brightness could come from a metallic or mirrored surface, and its steady movement without gas jets might suggest it's being propelled by something other than ice sublimation. But for every scientist willing to entertain the alien hypothesis, there are many more urging caution. They remind the public that strange data doesn't automatically mean something artificial, it could simply mean we haven't yet discovered the natural explanation. Space is vast and full of surprises, and even now, our understanding of interstellar objects is in its early stages. Still, the Hubble data continues to challenge expectations. The telescope's high-resolution imagery shows light fluctuations across the object's surface that don't match the typical spin patterns of comets. Instead of rotating evenly, 3I Atlas seems to pulse or flicker in brightness in a rhythmic but irregular way, as if different parts of its surface reflect sunlight differently over time. That could indicate a highly uneven structure, or, in a more speculative sense, some kind of design geometry. Whatever 3I Atlas turns out to be, scientists agree on one thing: it's one of the most extraordinary discoveries in modern astronomy. Every observation deepens the mystery instead of solving it. The object's size, brightness, and behavior continue to defy conventional explanations, forcing astronomers to re-examine what they thought they knew about how interstellar objects form and move. In the coming months, more data from Hubble, the James Webb Space Telescope, and ground-based observatories will help paint a clearer picture. But for now, 3I Atlas remains a brilliant enigma, an enormous, fast-moving, impossibly bright visitor from deep space that refuses to fit neatly into any known category. Whether it's a natural wanderer or something far more remarkable, it reminds us that the universe is still full of secrets waiting to be uncovered. The second interstellar visitor ever discovered, known as 2I Borisov, was first spotted by amateur astronomer Gennady Borisov. Unlike the mysterious Oumuamua, Borisov's comet behaved in a way that astronomers could actually understand. Its orbit had a very high eccentricity, around 3.4, compared to Oumuamua's 1.2, but despite its strange trajectory, everything else about it seemed normal. It had the tail of vaporized gas and dust that's typical of comets, and its composition matched what scientists usually see in icy bodies from our own solar system. The only truly unusual thing was its origin. It didn't come from here. Borisov served as the control experiment, the proof that interstellar visitors could exist and still follow the same physical rules as our local comets. But now comes 3I Atlas, the third interstellar object humanity has ever seen, and it doesn't fit neatly into any category. It's not as confusing and alien-looking as Oumuamua, but it's also far less predictable than Borisov. Astronomers are calling it a kind of cosmic hybrid. Its path through the sky doesn't match what models predicted for typical interstellar travelers. 3I Atlas is approaching from near the constellation Sagittarius, a direction that isn't aligned with the routes scientists usually expect for incoming interstellar objects. It's as if it appeared from a region of the galaxy that most simulations rarely produce. What makes it even more interesting is that it seems to blur the line between what we call a comet and what we call an asteroid. It doesn't display the typical long tail of vaporizing ice, yet it also doesn't behave like a simple, rocky asteroid reflecting sunlight. It occupies a strange middle ground, something that behaves like both, and neither. That's why scientists around the world are watching it so closely. Every new observation seems to add another layer of mystery instead of solving it. Recently, Harvard astrophysicist Avi Loeb and his colleague Eric Kito released findings that are sending shockwaves through the entire astronomical community. After carefully analyzing the brightness data from 3I Atlas, they noticed something that defied expectation. The object's brightness pattern didn't match any known reflective behavior. Instead, it looked as though 3I Atlas might be producing its own light. That idea sounds simple, but it changes everything. If the object is actually self-luminous, meaning it glows from within rather than reflecting sunlight, then all of the previous size estimates would be completely wrong. The original measurements, which suggested it might be 20 kilometers wide, assumed it was reflecting light like a natural object. But if it's generating its own light, then it could be much smaller, perhaps only a few hundred meters across. That's a massive difference, and it completely alters how scientists interpret the data. Loeb's calculations show that finding a natural interstellar object that large, 20 kilometers across, would be nearly impossible. There simply aren't enough big chunks of rock drifting between stars to make such an event likely. According to his estimates, a natural object that size would only enter our solar system about once every 10,000 years. That's why the idea of a smaller, self-illuminated object changes the game entirely. It opens up the possibility that we're not just seeing a big chunk of rock, but something else, something that could involve technology or physics we don't yet understand. So what could cause an object in deep space to generate its own light? There are a few possible explanations. One natural idea is radioactive decay. Some materials, like uranium or thorium, can release energy over long periods, which might produce a faint glow. But for that to happen in an interstellar object, the body would have to contain unusually high concentrations of those heavy elements. The chances of finding just the right combination of materials floating freely through space are extremely small. Interstellar space is a harsh, empty environment where radioactive elements would decay over time, making a persistent glow unlikely. Another natural explanation could involve chemical reactions within the object. If it contains certain reactive compounds or trapped gases, those could interact under cosmic radiation and create bursts of light. But again, the amount of light 3I Atlas gives off doesn't match the weak glow such reactions could produce. The luminosity readings are far too strong. That's why some researchers are beginning to entertain more exotic possibilities. If 3I Atlas is truly self-luminous, then perhaps it's powered by some form of internal energy source, maybe even an artificial one. It could be emitting light through a process similar to how spacecraft or satellites might use energy to stay visible or functional. Loeb and Quito have pointed out that, if this were true, the object's brightness could be intentionally designed, either as a signal or as a byproduct of its propulsion or power system. Even though that idea sounds like science fiction, it's based on solid data. The brightness doesn't vary the way sunlight reflections normally do. Instead, it seems consistent, as if the light comes from the object itself rather than being scattered by its surface. If that's true, it would represent a type of physics or engineering completely outside our current understanding. Still, most astronomers are cautious. They acknowledge that Loeb's theory is fascinating, but they also stress that natural explanations should be tested first. There may be unknown processes that cause natural interstellar objects to glow under certain conditions. Space is still full of mysteries, and our sample size of known interstellar visitors is tiny, just 3 objects. With so few examples to compare, it's difficult to draw firm conclusions. However, the implications of this discovery are staggering. If 3I Atlas truly is generating its own light, it could mean there are other, smaller objects out there doing the same, possibly remnants of ancient civilizations or technologies drifting through space for billions of years. Loeb's models suggest that self-luminous objects a few hundred meters across would be far more common than giant 20-kilometer asteroids. That means our telescopes might already be seeing faint traces of other interstellar travelers without realizing what they are. For now, scientists are continuing to gather as much data as possible. Telescopes across the world, along with space observatories like Hubble and the James Webb Space Telescope, are analyzing 3I Atlas's light curve, the way its brightness changes over time. Every new observation will help determine whether the object's glow is reflected sunlight, radiation from within, or something completely new. Regardless of what the answer turns out to be, 3I Atlas has already changed the conversation. It's forced astronomers to question long-held assumptions about how interstellar objects behave. If it's natural, it's an incredibly rare example of cosmic geology unlike anything we've seen before. If it's artificial, it would be the first direct evidence that we are not alone in the universe. Either way, this discovery reminds us how little we truly know about the cosmos. Somewhere out there, in the endless dark between the stars, objects like 3I Atlas could be quietly drifting, some made by nature, others perhaps by hands we've never met. Each one challenges us to look deeper, think bigger, and stay open to possibilities that stretch the limits of human imagination. Any natural radioactive material inside an object like this would need to produce about 10 gigawatts of constant energy, roughly the same as several big nuclear power plants running non-stop for millions of years. That's almost impossible for a natural body drifting through interstellar space. Another explanation could be thermal emission from internal heat, but that also doesn't add up. To shine as brightly as it does now, 3I Atlas would need an internal heat source producing temperatures of more than 1000 Kelvin. For comparison, that's hotter than molten lava and far beyond what solar heating could achieve at its current distance, about 4 astronomical units from the Sun. In simpler terms, this object is way too far and way too cold for natural processes to make it glow like this. And this is where the mystery takes an even stranger turn. If neither radioactivity nor natural heating can explain 3I Atlas's brightness, then one possibility remains: artificial illumination. That is, the glow might be coming from some kind of advanced technology, something far beyond what we currently understand. It sounds like science fiction, but the data pouring in from some of the world's most powerful observatories is forcing astronomers to take the idea seriously. Spectroscopic readings from the Gemini South Observatory and NASA's Infrared Telescope facility show that 3I Atlas's surface contains strong water ice signatures mixed with carbon-based minerals and silicates. On the surface, that might sound like a normal comet. Frozen water and rocky material are standard ingredients. But when astronomers dug deeper into the isotopic ratios of that water ice, things got weird. Those ratios don't match anything that should have formed in our solar system. They appear to come from an entirely different stellar nursery, formed billions of years ago somewhere far across the galaxy. In other words, this object is not only an interstellar traveler, it may literally carry the fingerprints of another star system's birth. It's like a frozen message in a bottle that's been drifting across the galaxy for eons, only now stumbling into our part of space. At first glance, this evidence seems to point to a comet-like object. But ironically, it could also tilt the case back toward the technology hypothesis. Imagine for a moment that 3I Atlas isn't a natural chunk of rock and ice at all. Instead, what if it's some kind of ancient probe, something designed or built by an advanced civilization long before humans even existed? The icy layers and dusty coatings astronomers are detecting might not be its true form at all. They could simply be a kind of cosmic camouflage, material it collected over billions of years as it drifted between stars. This would explain why it appears comet-like on the outside while behaving so strangely in terms of light and motion. If that's the case, then we're not just looking at another interstellar rock like Oumuamua or Borisov. We could be staring at the first known example of alien technology passing through our solar system. And if that sounds far-fetched, consider this: Harvard astronomer Avi Loeb, who already shook the scientific community by suggesting Oumuamua might be artificial, has publicly said that 3I Atlas's light profile and trajectory fit even less with natural explanations than anything we've seen before. The statistics also back this up. According to Loeb's calculations, the chances of finding a genuine 20-kilometer-wide interstellar asteroid are extremely slim. There simply aren't enough giant pieces of rock drifting between stars to explain something this big. It would take an extraordinary, once-in-10,000 years event for a natural object of this size to wander into our solar system. But a smaller, artificially illuminated object, perhaps hundreds of meters wide, would be far more likely, especially if it were built for interstellar travel and designed to stand out under certain conditions. This raises even bigger questions. What kind of technology could produce such a glow? What would be its purpose? And, perhaps most intriguingly, is it still active? The range of possibilities spans from natural processes we don't yet understand to outright artificial construction. In terms of natural processes, radioactive decay or trapped heat from formation are the usual suspects. But as already noted, both fail the energy test at these distances and timescales. Artificially generated light, on the other hand, opens a door to ideas that verge on science fiction, ancient interstellar beacons, probes equipped with energy sources we can't yet imagine, or even self-repairing machines drifting from one star system to another. The spectroscopic evidence adds even more intrigue. Those exotic isotopic ratios could mean the object really is just a comet from a far-off star. But they could also mean its material was deliberately chosen or engineered to survive unimaginable spans of time and space. Think about how we might design a probe to last billions of years. It would need to be durable, camouflaged, and maybe even capable of harvesting resources along the way, accumulating ice, dust, and rock as a kind of armor. That's the picture some scientists are starting to sketch in their heads. 3I Atlas could be an ancient traveler from another star system, carrying with it not just exotic materials but possibly technology or data. If that's true, it's a game changer for how we think about life and intelligence in the universe. It would mean we're not just passively observing space anymore. We're part of a story that stretches across billions of years and multiple solar systems. Even so, no one is jumping to conclusions just yet. Astronomy is a careful science, and extraordinary claims require extraordinary evidence. Teams around the world are racing to gather more data before 3I Atlas swings past and vanishes back into interstellar space forever. They're analyzing its spectrum, tracking its motion with the highest precision possible, and running simulations to test every natural explanation they can think of. But the clock is ticking. This interstellar visitor is moving fast, 58 kilometers per second, and it won't stay in our skies for long. If it really is artificial, it might be the only chance we ever get to study such an object up close. If it's natural, it could still revolutionize our understanding of how matter moves between stars, and how rare, or common, these interstellar messengers really are. Either way, 3I Atlas is forcing scientists to rethink the neat boxes they've built for comets and asteroids. It's neither fully predictable like Borisov nor bizarrely unexplainable like Oumuamua. It's something in between, a cosmic wild card. And in that middle ground, it might hold the key to one of the biggest mysteries of all, whether we're alone in the universe, or whether, just maybe, other civilizations have been sending out their own messages in bottles for far longer than we've been looking. All that icy dust and frozen material on 3I Atlas's surface could just be the interstellar dirt it picked up after drifting through space for millions, or even billions, of years. Space is messy. Any object, even an advanced machine, would end up coated in debris if it traveled long enough. That means the comet-like appearance of 3I Atlas might not actually prove it's natural at all. Instead, the evidence of ice and dust might be hiding something far stranger underneath, a technology or structure we simply can't see yet. But the mystery doesn't stop at its chemistry. If you think the material on 3I Atlas is weird, wait until you see its orbital path. This object's trajectory isn't just unusual, it's astonishing. Harvard astronomer Avi Loeb and his team wrote a paper with the blunt title, "Is the Interstellar Object 3I Atlas Alien Technology?" and then they ran the numbers. What they found was enough to make even the most skeptical scientists uneasy. First, 3I Atlas is on a retrograde orbit. In simpler terms, that means it's moving upstream against the usual direction of planets and most objects in our solar system. Natural interstellar visitors already have unusual orbits, but this is still rare. Stranger still, its path isn't tilted randomly. Instead, it's inclined by only about 5 degrees from the ecliptic plane, the flat disk where our planets orbit the Sun. For a random interstellar object, the chance of this happening is roughly 0.2%, about 1 in 500. That's already eyebrow-raising. But things get even more incredible. As 3I Atlas approaches our solar system, it isn't just flying by randomly. It's weaving through a series of near encounters with planets that look almost like a trick shot in a cosmic game of billiards. On October 3rd, it will pass within about 29 million kilometers of Mars. By October 29th, it will reach perihelion, its closest point to the Sun, at just 1.35 astronomical units, AU. Then, not long after, it will swing within 33 million kilometers of Jupiter. The statistical odds of a single interstellar traveler hitting all three of these marks at that level of precision are unbelievably small, about 0.0005%, or 1 in 20,000. That's not just unusual, that's practically unheard of. Even experienced astronomers who are normally cautious about big claims admit that this trajectory is startling. It's not just a weird comet anymore, it's something that appears to be navigating a path almost as if planned. And the timing makes things even spookier. 3I Atlas reaches its closest approach to the Sun exactly when Earth is hidden on the opposite side. During that most critical window, we can't directly observe it. The Sun's glare completely blinds every telescope we have, blocking our best chance to study it up close. If someone were designing a craft to slip through our solar system unnoticed, that's exactly the kind of timing they'd pick. It's almost as if the object planned its entrance to avoid detection during its most revealing moment. This combination of unusual chemistry, odd brightness, retrograde orbit, low inclination path, and eerily perfect timing is why astronomers around the world are on edge. The simplest explanation, that it's just a very weird comet, is starting to look less and less satisfying. Yes, it's possible for natural objects to have strange orbits and unusual compositions. Space is full of surprises. But when so many unlikely factors line up at once, the mind starts to wander toward other possibilities. One of those possibilities is that 3I Atlas isn't just a rock or a ball of ice but some kind of ancient interstellar probe, a machine built by an unknown civilization long ago. If that's the case, then the icy coating we see could simply be a disguise or protective layer collected over time. The unusual brightness could be its power source, an active signal, or even some technology we can't yet identify. Astronomers like Loeb are careful not to make bold claims without evidence, but they also aren't ignoring the data. This object is challenging the very way we classify and understand celestial bodies. It doesn't fit neatly into the comet or asteroid categories. It's something in between, or maybe something entirely different. The orbital mechanics alone push it toward the extraordinary. Interstellar objects don't normally thread through planetary encounters like this. Their paths are usually random, shaped by chance gravitational nudges. But 3I Atlas's path looks like a precision route, as if someone calculated how to use the planet's gravity fields to steer it exactly where it needed to go. That's a hallmark of intelligent navigation, not random motion. And then there's the timing of Earth's position. If you're trying to avoid observation from a planet full of telescopes, you'd want to pass by when that planet is hidden by the Sun, exactly what 3I Atlas is doing. Maybe it's a coincidence. But when you add that to everything else, the brightness, the composition, the path, and the rarity, it stops feeling like chance. Even so, no one is ready to declare 3I Atlas an alien probe. Science doesn't work that way. Teams all over the world are scrambling to gather as much data as possible before it leaves our skies. They're studying its light spectrum, tracking its movement with extreme precision, and running computer simulations to test every natural explanation they can imagine. But time is running out. This object is moving at 58 kilometers per second, and it won't linger near us for long. Once it slingshots around the Sun and heads back into deep space, we might not get another chance like this for thousands of years. If it's artificial, this could be the only moment in human history when we can study an alien craft up close. If it's natural, it could still completely reshape our understanding of how material travels between stars. Either way, 3I Atlas is more than just another interstellar visitor. It's a test of our ability to recognize something truly extraordinary when it's right in front of us. For decades, scientists have wondered if alien civilizations might send out probes to explore other star systems. What if that's exactly what we're seeing now, but because it looks like a comet, most people assume it's nothing unusual? This is why so many astronomers are glued to their data and their screens. 3I Atlas might just be another cosmic rock. Or it could be the most important discovery in human history, hiding in plain sight under a layer of ice and dust. As it speeds through our solar system on its improbable path, we're left to wonder, is this just a piece of interstellar debris, or is it someone else's message in a bottle, drifting across the galaxy, finally reaching our shores? To Avi Loeb, the whole situation looks suspiciously like what's known as a reverse solar orbit maneuver. This is a clever braking strategy a spacecraft could use near the Sun. By firing its engines at the right moment close to the Sun's gravity well, a craft could shed speed, essentially using the Sun to slow itself down instead of speed up. Done correctly, this maneuver could even allow a spacecraft to settle into our solar system, quietly anchoring itself without anyone noticing. And the most astonishing part? The timing. Earth's astronomers would be forced to look away at the very moment this critical maneuver happened, blinded by the Sun's glare. It's the perfect strategy for a stealth arrival. Of course, most of the scientific community isn't ready to jump to the alien explanation. The majority of researchers still say it's just a comet behaving strangely, not an alien craft. David Jewett of UCLA, who's leading the Hubble Space Telescope's observation campaign of 3I Atlas, points out that the object is producing dust at a rate between 6 and 60 kilograms per second, well within the expected range for a standard comet. The dust speeds, measured between 20 and 2,000 meters per second, also match what we've observed in other comets. In other words, nothing in the dust production screams alien engines. Even the absence of certain volatile gases, like cyanogen or diatomic carbon, doesn't prove anything unusual. Those gases typically appear when a comet gets much closer to the Sun, as the heat causes the more fragile materials to sublimate. Right now, 3I Atlas is still sitting about 4 astronomical units away from the Sun, around the distance of Jupiter. At that range, many comets haven't started releasing their more exotic gases yet. In other words, 3I Atlas could simply be a late bloomer in terms of outgassing, and the missing gases might show up as it dives deeper toward the inner solar system. Then there's the self-illumination debate. A few theorists have proposed that if 3I Atlas's brightness anomaly isn't just reflected sunlight, then maybe the object is actually generating its own light. The problem is that doing so would require an energy output of around 10 gigawatts of continuous power. To sustain that for millions of years of interstellar travel, the object would need an unimaginable amount of fuel or a technology far beyond anything humanity can currently imagine. Even in the most speculative engineering concepts we have today, there's nothing close to that level of efficiency. For most scientists, this is where they draw the line. A self-powered, self-illuminating alien spacecraft is simply too far-fetched to take seriously, at least without hard evidence. But here's where things get more interesting. Even among the skeptics, there's a quiet unease. Multiple astronomers, speaking off the record, have admitted that while they personally believe 3I Atlas is a natural object, they still can't fully explain its brightness anomaly. And that is the heart of the mystery. All the normal comet behavior, the dust production, the gas releases, the speeds, checks out. But the brightness, the unusual trajectory, and the uncanny timing still sit there, stubborn and unexplained. It's as if 3I Atlas is walking the razor's edge between a perfectly natural comet and something far stranger, keeping everyone guessing as it hurtles past us. Some scientists have even admitted privately, if the self-illumination idea ever turns out to be true, it would be the single most important discovery in human history. You can almost feel the tension behind those words. They don't want to openly claim that 3I Atlas might be alien technology, but they also can't completely dismiss the mystery either. It's that uneasy space between the data and the explanations that keeps the astronomical world on edge. And now, all eyes are fixed on the next few months, because this upcoming observation window isn't just another step in the investigation. It could be the defining moment of modern astronomy. As 3I Atlas drifts closer to the Sun, it should begin showing more obvious comet-like behavior, gas jets, vapor trails, and distinct emissions, if it truly is a comet. But if those signatures fail to appear, it'll be another major strike against the natural theory. The James Webb Space Telescope is already preparing for its turn. Its schedule has been cleared to study 3I Atlas's infrared profile in extreme detail. With Webb's instruments, scientists will soon be able to measure the object's temperature and energy output more accurately than for any interstellar visitor in history. This could finally tell us whether the strange light we're seeing comes from reflected sunlight, or something generating its own glow. But the most exciting part might not even come from Earth's perspective, it might come from Mars. In early October, when 3I Atlas passes near the red planet, NASA's Mars Reconnaissance Orbiter will attempt to take high-resolution images using its HiRISE camera. Just imagine that, for the first time ever, we might get an actual close-up view of an interstellar object's surface. Not just a fuzzy dot or a streak of light, but real visual data that could show texture, structure, and even hints of what it's made of. If those pictures succeed, they could answer one of the biggest questions in modern science. Is the light we're seeing from 3I Atlas just sunlight bouncing off frozen ice, or is it something glowing from within, powered by an unknown mechanism? And it won't just be one spacecraft taking part. Both Mars Express and the ExoMars Trace Gas Orbiter will also join the mission, coordinating to build a three-dimensional view of 3I Atlas from multiple perspectives. Together, these orbiters will create a layered picture of how the object behaves as it passes near Mars, something humanity has never done before with an interstellar visitor. Timing, however, is absolutely critical. When 3I Atlas makes its closest approach to Mars, it will still be far enough from the Sun that scientists can distinguish between natural and artificial light signatures. Once it dives deeper into the inner solar system, though, the Sun's intense heat could interfere with those readings, making it almost impossible to tell the difference. That means the October observation window is priceless, a short, irreplaceable moment to capture the truth before sunlight and physics blur the clues forever. The implications are massive, and they're keeping scientists around the world awake at night. If 3I Atlas behaves like a normal comet, the mystery might fade, even if the story remains fascinating. But if it doesn't, if it continues to defy expectations, then the conversation shifts entirely. It would mean we've just witnessed an object, or perhaps a craft, from beyond our solar system behaving in ways nature alone can't explain. The next few months will tell us whether 3I Atlas is simply another piece of cosmic rock, or the first confirmed sign that we are not alone. Now let's zoom all the way out and look at the bigger picture. If the artificial object theory is correct and 3I Atlas really is some kind of machine, then we're not just looking at a glowing rock. We'd be watching something that's following a perfectly calculated path, slipping past 3 planets, avoiding Earth's direct view, and maybe even slowing down so it can linger in our solar system. That idea raises questions almost too big to process. Why would it arrive during solar maximum, the period when the Sun's activity makes detection most difficult? Why would it time its closest approach to the Sun for the exact moment when Earth is on the other side and can't observe it? Why pass near Mars and Jupiter as if it's surveying them? These aren't random moves, they look like a plan. Even NASA's own OITS software, the same tool used to plan real space missions, has been used to simulate 3I Atlas's movements. And the results are chilling. If this object had even a small amount of thrust, it could easily change its course and remain trapped inside our solar system indefinitely. Just think about that, something arriving from deep space, then choosing to stay. Of course, there's still a chance it's natural. Maybe it's just an incredibly rare outlier that exposes gaps in what we think we know about physics and comets. But whether it's alien or not, the takeaway is the same: our universe is far stranger than we imagine. And this may only be the beginning. The Vera C. Rubin Observatory, which has just started its full operations, is expected to discover dozens of new interstellar objects every year. Very soon, we'll have enough examples to tell the difference between what's normal and what's truly rare. 3I Atlas might be the warning sign, the canary in the coal mine, showing us how little we actually understand about interstellar wanderers. There's also a countdown ticking. Astronomers are calling the next few months the point of no return. If 3I Atlas does have the ability to maneuver, it has until early November to make its move. After that, its hyperbolic orbit will sling it out of the solar system forever, never to return. There are 3 key checkpoints ahead: the October Mars encounter, the hidden perihelion behind the Sun, and the December Earth flyby. Each one is an opportunity to catch the object in the act, whether it's vending ice like a comet or firing engines like a craft. After those dates, the window closes. And here's the question that keeps researchers awake at night: what if all of this timing was deliberate? What if it was launched to arrive right now, during the exact era when our technology is advanced enough to detect it, but still too primitive to chase it, stop it, or even communicate with it. If that's the case, then we may be standing at the edge of something truly unprecedented in human history. Stack up the coincidences. Approaching from the galactic center during solar maximum. Traveling on a retrograde orbit, swimming upstream against the current, yet perfectly aligned with our planetary system. Reaching perihelion exactly when Earth is hidden behind the sun, glowing in ways that still don't add up. One or two coincidences you can excuse. But when the list grows this long, even hardened skeptics start to sweat. Either nature is capable of some bizarre, orchestrated magic, or someone else is writing the script. And that's why 3i Atlas matters. Because in the next 3 months we're going to find out whether the universe occasionally rolls dice with impossible odds, or whether we're not alone. Both answers are seismic. Both fundamentally change what it means to be human. Even if it proves natural, the lessons will ripple across science, forcing us to rethink how interstellar bodies form, behave, and move through the galaxy. If it's artificial, then history will split neatly into before 3i Atlas and after 3i Atlas. Either way, astronomy, and our understanding of reality, will never be the same. We just aren't ready for it. Ready for more groundbreaking discoveries about our galaxy and beyond? Subscribe now and stay ahead of how humanity's future is being shaped by these cosmic revelations.